Hello everyone, I'm Ben, and this is an analog voltmeter. These things used to be very commonly used to measure all sorts of voltages, but with the advent of digital meters, they're nowhere near as common as they used to be. And you can also tell with this one, because it's an all-plastic construction, that this is a fairly late model, probably well into the time when digital meters were commonly being used in some places. But today, I'm not going to be using this to measure voltages. Well, I guess technically I am. I'm going to try to set this up to be controlled by a microcontroller. First, however, I'm going to just test it out on the supply and make sure this one works. Also, sorry about the noise. This power supply is very loud. In a moment, I'll power this from something else, so we won't need to use this power supply. But let's just see if 1 volt looks like 1 volt. Alright, hopefully that's a slightly better view, but you can still see the power supply. 1 volt, 2 volts, 3 volts, 4 volts, and the top of its range 5 volts. So that looks to be doing alright. So, as we've seen, this device goes up to 5 volts, but most modern microcontrollers only use 3.3 volt logic, so we'd only get, 2/3 of that range. So, you could build up some sort of a voltage boost circuit that would let you control 5 volts. Instead, I'm going to use this Arduino Mega, which has 5 volt outputs natively. So I've now wired up this gauge to one of the pulse width modulation outputs on the Arduino. In this case, I've picked pin 7. So in the Arduino IDE here, I have a simple sketch. I'm just setting up a define for the meter pin, enabling that pin as an output, and then setting the value 128 to it. And then with that, we can see that the meter now goes to the middle. So here, I've moved the analog writes into the loop, and I've got 4 of them at 0, 50%, 100%, and 50%, with a 500 millisecond delay between them. So when I upload this, we will see that the needle goes to 0, and then jumps to the middle, and then the top. So as we see, the meter takes just a moment to hit its position if we just tell it to jump. We might be able to improve that a little bit if instead we make it ramp slowly to the target position. So here's the next bit of demo code. This time, hopefully, it will ramp to the halfway point over about a half a second, and then hold there for 2 seconds, and then ramp up to full, and repeat that for several different values. So let's see this in action. So as we can see now, when we're ramping slowly between the different values, it gets to each of the values and stops without overshooting near as much or making any of the little clicking noises. One thing to note here is that we have a resolution of 256, since that's the output resolution of the Arduino Mega, and a lot of other boards also only have an 8-bit PWM output. But on an analog meter, that's probably just fine. We could probably get away with even 16 different values for it to be, just because they're not that precise to easily read. Here's one last demo to wrap up with. This one just smoothly sweeps the needle back and forth in about 10 seconds. So this has been a brief exploration of analog meters. Maybe at some point in the future, I'll incorporate one into one of my projects. Thanks for watching.